Quadratic functions. We've been spending a lot of time working with quadratics and solving them using completing the square, factoring, or the quadratic formula. Today we're going to take a look at a very important point on a quadratic function, and that point is the vertex. Quadratic functions, first in way of definition, have a quadratic term or an x squared term, like 3x squared minus 5x plus 1. And on every quadratic function, you'll notice that it starts out in one direction. This top graph goes up. Then it levels off. And then it goes back the other direction. It makes this shape that we call the parabola. It can go the other direction too, opening up, where it starts going down, levels off, and then goes the other direction. That general shape, parabola, is the graph of every quadratic. And the most important point on the quadratic function is the vertex. The vertex is either the maximum point, if it's a graph that starts going up and then turns down, or the minimum point. But basically, it's that point where the graph changes direction. So today we're going to see if we can find the vertex of various quadratic functions. The easiest way to do that is if the quadratic function is actually written in what we call vertex form. Vertex form is when the function f of x is equal to something times x minus h squared plus something. If it's in this form, the vertex is at the point h, comma, k. h, comma, k. One thing I want to notice is the h is negative in the formula, but it's not negative in the vertex point. Batman and Robin had a huge conversation about this. Robin claimed the vertex of x plus 3 squared plus 5 is 3, 5. But you'll notice we need to take the opposite sign, not plus, but minus. So Batman's correcting him here ever so gently, as Batman does. No, it's negative 3, 5, because it's the opposite of the h. The k is the same, but the opposite of the h. So if I've got the function negative 3 times x plus 2 squared minus 1, the 2 is my h and the 1 is my k. I just have to remember that I need to take the opposite of the h. The opposite of the h is negative 2, and then take the k as it comes, which is negative 1. The vertex is at negative 2, negative 1. That's where the graph will change directions. However, most of the time, it's not in vertex form. It looks like negative 2x squared minus 8x plus 3. So how do we get it into vertex form? We use our old friend completing the square. Here's how we complete the square to get in vertex form. It's very similar to solving, just a few tweaks we have to make because we're not working on both sides. We're only working on one side. First, we factor a out of the first two terms. So that's a. We're going to factor it just out of the first two terms. So we factor out a negative 2. That's how we get the a out of the way. And that leaves us with x squared minus, well, actually, negative divided by negative is a positive. 8 divided by 2 is 4x. And that plus 3 is out of the way. So now we've taken care of the a, and we've also taken care of the constant term. Now we're ready to find that magic number, that b, which is 4 here, divided by 2 and square it. Well, 4 divided by 2 is 2 squared. 2 times 2 is 4. And just like we did before with that magic number, we're going to add it. But we only have one side of the equation to work with. So we're going to add it inside the parentheses to make that part a perfect square. And we're going to subtract it from the end. Put it in and take it out. Because we're working on one side of the equation and we can't change the value. So if we add 4, we have to also subtract 4 to balance out. But we need to remember, and this is the most common error here, we've got an a out front. We have to multiply by that number out front. Because when it distributes through, that's actually negative 2 times 4, negative 8. So we need to undo that as well. So we times a, very important. Add and subtract, but times a when we subtract. So now when I do that, I've got negative 2 times x squared plus 4x plus 4. And then negative 4 times 2 is positive 8. So we've really got 3 plus 8, which is a positive 11. Now we're ready to factor my problem. So we have negative 2 times x plus 2 squared. We should be really good at factoring that perfect square plus 11. And now f of x is in that perfect vertex form. We can identify h and k. Remember, h has to be the opposite. So the opposite of 2 is negative 2. Take k as it comes, 11. And the vertex of this function is negative 2, comma, 11. That's the process we have to go through in order to identify the vertex of a function by completing the square. The process of completing the square should look really familiar to you. We're just going to tweak it so we're only working on one side of the equation. So let's do one more example. First, factor out a. So we factor out a 3. Leaves behind x squared plus. Notice we can't divide 2 by 3. So sometimes we have to force it to work. We're going to end up with a fraction by dividing the 2 by 3, giving us 2/3 x, and then a minus 5 at the end. Next, we're going to find that magic number. That magic number uses the b, the middle term, which is a fraction this time 2/3. So instead of dividing by 2, we're going to multiply by a half and then square it. What's nice here is the 2's divide out, and we have 1/3 squared, which is 1/9. So what we're going to do is we're going to add the 1/9 inside the parentheses and subtract the 1/9 from the end. But remember, we have to always multiply by the a. Well, 3/9, that's nice. It's going to reduce. 3 over 9 is going to actually be, let's see what we have. We have a negative 5 and a minus 1/3. So to get a common denominator of 3, we need to multiply both by 3. So we have negative 15 thirds minus 1/3. That's negative 16 thirds. So a little bit of fraction work. We had to simplify. We had to get a common denominator. And then we have all this stuff out front. 3 times x squared plus 2/3 x plus 1/9. And it is finally ready to factor. Fortunately, it factors really quickly. X, sign from the middle, plus square root of 1/9 is 1/3 minus 16 thirds. And now we are in vertex form. We can see the vertex is at the point h, comma k, but we have to take the opposite of h. So the vertex is at negative 1/3, comma, negative 16 thirds. A little bit more work because it was a fraction, but not too tough to identify. We can find any vertex by completing the square on the quadratic. So take a look at the homework assignment. Practice a few of these. We should be very familiar with the process to complete the square. We're just tweaking it so that we only work on one side of the equation. Good luck.